Good morning, everyone. Thank you for joining me today. I'm excited to introduce you to Microidea, an online tool we've developed to help extract and analyze job data from online postings. This project, funded by the European Union and led by the Data and Media Lab at the University of Peloponnese, has been launched in April 2024. Let's dive in. This slide provides an overview of what we'll be covering today. First, we'll introduce the online tool and its purpose. Then we'll move on to an overview of how the tool is implemented. Lastly, we'll dive into the key processes that power this tool, starting with data crawling and extraction, which involves both back-end and front-end components. After that, we'll discuss data deduplication, focusing on how the back-end processes ensure clean, non-redundant data. Next, we'll cover AI-assisted metadata extraction, explaining how we use prompting and structured data to gain deeper insights. Finally, we'll end with text normalization, showing how we cluster and visualize the data to provide a clearer picture of the labor market. The main goal of Microidea is to streamline the way we extract and analyze data about occupations and skills from job postings. We're using advanced technology, including machine learning and natural language processing, to ensure we gather accurate data. Additionally, large language models help us understand the text in job postings, while text embeddings match job descriptions with relevant skill categories. This approach will make it easier to process and understand labor market trends. Job data analysis has come a long way thanks to the introduction of large language models, or LMs, such as transformers. These models have made it possible to process large amounts of unstructured job-related data much faster and more accurately. This technology helps us understand job descriptions and candidate profiles in a more detailed, contextual way. Plus, it automates the extraction of key information like skills and qualifications, which is critical when you're dealing with huge data sets. Here's how Microidea works. There are two main phases. First, we gather job-related data from various online sources. Then we clean, deduplicate, and standardize it. This makes sure the data is consistent and reliable. In the second phase, we apply advanced AI models to interpret and analyze job postings. This phase extracts key information, like job titles and required skills, and categorizes it using established taxonomies like ESCO and NACE. By doing this, we create a comprehensive, organized database that helps track labor market trends. Our system continuously pulls data from multiple online sources. We use web crawlers to collect job postings every day, ensuring that we're always working with up-to-date information. The data we collect includes job titles, descriptions, employer details, and skill sets. Before we use this data, we clean and standardize it, ensuring high quality. We also provide multilingual support, and we're currently working on adding Spanish and Cypriot Greek job portals to the mix. Now let's take a look at the backend. This is where all the data we crawl is stored and managed. We use PHP-MyAdmin and MariaDB to organize the job postings and employer data. The database structure is carefully designed to handle the different elements we extract, making it easy to analyze and categorize the data. Here's a closer look at the key tables in the database. These tables store essential job market data, like job postings, companies, and the skills required. This structure allows us to easily manage and categorize job postings, making the data ready for analysis. In this example, you can see how we capture specific job-related fields, such as the job title, description, location, and employer. This organized structure ensures that the data is easy to search, filter, and analyze. To access the Microidea platform, users log in through this secure interface. We ensure that only authorized users have access to the data, keeping the system secure and protecting sensitive job-related information. Once logged in, users see a dashboard that displays daily scraping statistics from job portals. The dashboard provides key insights, such as how many job postings were collected and categorized, giving an overview of the system's activity in real time. Here's what a job posting looks like in the system. Users can view details such as the job description, company information, location, and posting date. This allows for an in-depth examination of each posting directly within the platform. Now, let's move on to the company database. Here, users can view detailed records of employers, including their addresses and NAICE codes. The platform also allows for editing and managing company information efficiently. Finally, we show how job titles are linked to skills and qualifications using ESCO data. This helps us categorize and visualize the competencies required for each job. It's a powerful way to understand the skills landscape for different positions. One of the challenges in job data collection is dealing with duplicate entries when the same job is posted on multiple platforms. Our deduplication process ensures that we only consider unique job listings. First, we apply similarity checks to spot exact or near exact duplicates. Then we use LLMs to refine this process, ensuring we don't remove unique listings by mistake. This results in clean, reliable data that accurately reflects the labor market. This slide shows how the deduplication process works in the back end. It starts by loading the job data, then goes through each pair of job postings to compare them. If they are too similar within a certain time frame, the system flags them as duplicates. This process ensures we are left with unique, accurate data. To ensure accuracy, we also allow for manual inspection of flagged duplicates. The system generates HTML files that highlight differences between similar job postings, allowing users to review and confirm whether they are duplicates or not. Our system also uses AI-powered evaluation to explain why certain job postings were flagged as duplicates. This slide shows how the system breaks down the similarities and differences, providing an extra layer of validation. Let's talk about metadata extraction. Before we extract metadata, the job data is cleaned and normalized to ensure high quality. Then we use large language models to extract key information from each job posting, such as job title, company name, skills, and salary. This information is then structured in a JSON format, making it easy to analyze and integrate with other systems. In this slide, we start with the raw data from the job postings. This includes all the details related to job titles, descriptions, and other key fields that will be processed. The data is prepared and loaded into the system for further analysis. Next, we use prompting techniques to extract the key elements from the job postings. By utilizing large language models, we are able to intelligently guide the system to focus on specific fields, such as job titles, skills, and qualifications. This slide illustrates the fields that are used as prompts for the AI model inference. These fields help structure the extraction process, ensuring that the system can accurately gather and analyze the most important aspects of the job postings. We guide the AI by focusing on key fields within each job posting. For example, job titles provide an initial understanding of the role from the job description. Company and location details enable geographic and industry-specific analysis. Skills and qualifications are extracted and standardized to align with recognized frameworks. These prompts ensure the model processes job data efficiently, transforming unstructured information into clear, actionable insights for labor market analysis. Here's an example of how the AI system structures the job posting fields. As you can see, the fields are organized in a clear and structured way, making it easy to analyze the information and integrate it into further workflows. Now, we move on to the extraction of ESCO and NAICE classifications. Using embedding models like BERT, we can match job titles with ESCO occupation descriptions based on semantic similarity. This process enriches the job data with additional metadata from ESCO, which helps improve the classification of jobs. We apply similar methods for NAICE, categorizing jobs into economic sectors like engineering, IT, and business. This standardized classification supports more detailed economic analysis. These slides show how Microidea visualizes normalized job data. Using embeddings and matching techniques, job titles are linked to frameworks like ESCO, enriched with metadata, and classified by sectors using NAICE. This process results in clear visualizations that help stakeholders analyze trends, identify skill gaps, and track labor market developments. Lastly, we have the AI-assisted clustering of job titles. This feature helps categorize job titles based on their connection to specific sectors, such as tourism. The system uses AI to understand the text and group job titles into three categories: direct connection, indirect connection, and no connection to the sector. This clustering gives us a better understanding of how various jobs fit within specific industries. Here's an example of the clustering results. You can see how job titles are divided into the three categories: directly connected, indirectly connected, and not connected to the tourism sector. This tool will help industries like tourism better understand the labor market and the availability of relevant skills. This slide showcases an interactive visualization of job titles directly connected to a specific sector. Each node represents a job title, and the connections show how these roles are related within the broader industry. Users can explore this map by clicking on individual nodes or leaves. When a node is selected, detailed information about that job title is displayed below, including its classification, ISO code, and a description. This example shows the role of waiters with relevant details, such as a description of tasks, alternate labels, and links to additional resources. This tool allows for easy navigation through different job roles, providing quick access to comprehensive job information from trusted sources like ISO. That brings us to the end of our presentation. Thank you all for your attention and participation. If you have any further questions or would like more information, feel free to reach out. We're excited about the potential of Microidea to transform job data extraction and analysis. We look forward to your feedback and possible collaboration. You can also scan the QR code on the screen for additional resources and project details. Once again, thank you.